In this video, we're going to be looking at page 590, problem 4, and I did not assign this problem as a homework problem because I wanted to use it as an example. So kind of a bonus. I didn't have that on the note sheet before. So this says, for the discrete random variable x, remember discrete means that you're getting separate values, and discrete always comes up from counting. All right. So discrete comes from counting. So we have a discrete random variable x, and the probability distribution is given by this formula. And then they want us to find the value of the constant k and then the expected value of x. So since they're giving us the probability distribution formula, what we'll do is we'll fill in the probabilities, the probability distribution in this row. So this says if x is equal to 1, 2, 3, 4, or 5. So in other words, for all of these, 1, 2, 3, 4, 5, we're going to use this formula. Now notice, the first one, x is 1, so we're going to sub 1 in for x. X is 2, so we're going to sub 2 in for x. So we're going to end up with, when we do that, first we sub in the 1 for x, so we just get k. Now we sub in the 2 for x, so we get 2k. The next one we're subbing in 3 for x, so we get 3k. And then down the line, the next one is 4k. Next one is 5k. All right, then we come to x equal to 6, 7, 8, and 9. 6, 7, 8, and 9. And that means we're going to sub into this formula. So when I sub in the 6, I get 6 times 10 minus 6. Right? I'm sorry. Back up. This is k times 10 minus 6. So that's going to be 4k for this one. Then the next one, we're going to have k times 10 minus 7. So that's going to be 3k. The next one is going to be k times, I'm going to squeeze this in here a little bit differently. Next one's going to be k times 10 minus 8. So that's going to be 2k. And then the last one is going to be k times 10 minus 9, which is 1k, or just k. So if I'm going to find the value of k, what you need to remember for this one is that the sum of all of these entries have to add up to 1. So if I add those up, I'm going to have 3k, 6k, 10k, 15k. So let's go ahead and write that, 15k. Plus 4k, 3k, 7k, 9k, 10k. Right, and that equals 1. So that means I'm ending up with 25k is equal to 1. So k is equal to 1/25. So if we could, at this point, we're going to have to find the expected value of x. So if we have to find the expected value of x, then what we would want to do is know what these probabilities are. So if I substitute the 1/25 back in, I end up with 1/25, 2/25, 3/25, 4/25, 5/25, which is just 1/5, but I'm going to go ahead and leave it as 5/25 so I can add these up. Next one is 4k, we already have that, so 4/25, 3k is 3/25, 2k is 2/25, and then 1k 1/25. So now, to get the expected value, remember again that the expected value is the sum for I equal 1 to however many terms there are. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So I is going to take on the values 1 through 9 of, and again, what we want are all the x sub I values times their corresponding probabilities. So if I sub in the 1 first, I end up with x sub 1 times p sub 1, plus, now I sub in the 2. So if I sub in the 2 in each of those places, now I get x sub 2, p sub 2, add, and then all the way down the line. So x sub 3, p sub 3, plus x sub 4, probability 4, plus the fifth value of x times probability 5, plus x sub 6 times probability 6, plus x sub 7 times probability 7, plus x sub 8 times probability 8, plus x sub 9 times probability 9. So now we're just going to sub in all of those values. So the first one we get 1 times 1/25, so I'm taking the values from up here, 1 times 1/25, and then I'll have 2 times 2/25 and so forth. So this turns into 1 times 1/25 plus 2 times 2/25 plus 3 times 3/25 plus 4 times 4/25 plus 5 times 5/25 plus 6 times 4/25, so that's right down here, so 6 times 4/25 plus 7 times 3/25, again just double checking these, plus 8 times 2/25 plus, and then the last one we have 9 times 1/25. So what happens is we're going to get just a whole bunch of fractions from all of these that have a 25 in the denominator, because you can think of the whole numbers as being that number over 1. And then we can add up the numerator. So I'm just going to kind of do everything in one step. So I end up with 25 in the denominator. So up here, the 1 times 1 is 1, so I'm just going to have a 1/25. The next one's going to be 4 plus 9 plus 16 plus 25 plus 24 plus 21 plus 16 plus 9. So those are all of the values that we have up in the numerator. So now we need to add those up. So when I add those up, I end up with 5 plus 9 is 14, 30, 55. If I add this, I get 79. I get 80 plus 20 is 100, 116, 125. So I get 125 divided by 25, which is 5. And that's my expected value of x, or what we call the mean value.